I can almost guarantee that at some point in your life, you have stood on a moving escalator, looked down at those stiff black brushes lining the metal sides, and slowly slid your shoe against them. Maybe you wanted to clean some mud off your sole. Maybe you wanted to scuff your sneakers. Or maybe you were just bored on the way to the food court and thought the mall had installed a free automatic shoe shiner just for you. But what you did not realize is that by pressing your shoe against that brush, you were dangling your toes mere millimeters away from an industrial meat grinder. Those brushes are not there to polish your leather. They are a desperate, highly engineered safety device, and they are the only thing standing between you and a catastrophic mechanical amputation. To understand why those simple black bristles are a matter of life and death, we have to look past the shiny silver steps and understand what an escalator actually is. When you step onto an escalator, you are not just stepping onto moving stairs. You are stepping onto the back of a massive 10-ton piece of heavy industrial machinery that has been hidden beneath the floorboards of your local shopping mall. An escalator is essentially a giant continuous tank tread. It is powered by massive electric motors and heavy steel drive chains that generate thousands of pounds of torque. This machine does not care if it is pulling a metal step or a human leg. It simply turns endlessly and powerfully until someone hits the emergency stop button. But the most dangerous part of this massive machine is not the moving steps themselves. The danger lies in a tiny, almost invisible gap known in the engineering world as the skirt clearance. The skirt is the stationary metal wall on the left and right sides of the escalator. The steps have to move past this wall, which means they cannot be perfectly attached to it. There must be a small gap, usually only a few millimeters wide, to allow the metal stairs to glide up and down without scraping the sides. For decades, this tiny gap was a hidden nightmare. Here is the terrifying physics of what happens in that millimeter of space. Let's say you are wearing a soft rubber-soled shoe, a classic sneaker, a slip-on, or a pair of Crocs. You stand on the edge of the moving step, and the side of your rubber shoe brushes against the stationary metal skirt wall. Because the step is moving forward and the wall is standing still, the rubber of your shoe creates immense sliding friction against the metal panel. Friction generates heat, and it makes the rubber sticky. If you press just a little bit too hard, the sidewall grips the rubber of your shoe like an eraser on a piece of paper. Once the wall grips the shoe, the immense forward power of the electric motor keeps pushing the step forward. The shoe is suddenly pinched. Before you can even react, the mechanical torque violently drags the soft rubber of the shoe directly down into that tiny, millimeter-wide gap. In the escalator industry, this is called an entrapment, and it happens faster than the human brain can process. Once the toe of the shoe is sucked into the gap, the machine acts like a massive mechanical wedge. It pulls the fabric, the rubber, and the foot inside, crushing bone and tissue in a fraction of a second. In the 1980s and 90s, before global safety standards were drastically updated, escalator entrapments were a terrifyingly common occurrence, especially for young children wearing soft rubber shoes. The friction would grab their tiny shoes and pull them into the machinery, resulting in horrific injuries, deglovings, and amputations. The engineers and designers realized they had a massive crisis. They couldn't completely close the gap because the metal steps needed room to move. They couldn't change the laws of friction, so they had to figure out a way to manipulate human psychology. They had to keep feet away from the edge without building a solid wall. Their brilliant solution was a piece of equipment officially known as a skirt deflector. You know it as the escalator brush. The skirt deflector is a masterpiece of psychological and physical engineering. It operates on a biological principle known as tactile feedback. Humans are incredibly bad at judging distance with their eyes when looking straight down at their feet, but our nervous system is incredibly fast at reacting to physical touch. By installing stiff nylon bristles along the sides of the escalator, engineers created a physical warning track. When you lazily stand too close to the edge, long before your rubber shoe can touch the dangerous metal wall, you feel the stiff bristles brushing against your ankle. The moment your skin or your shoe feels that unexpected friction, your spinal cord sends an instant reflex signal to your brain. Without even thinking about it, your body instinctively flinches and pulls your foot an inch toward the center of the step. It is a subconscious safety alarm. The brush screams at your nervous system to back away from the death zone. Furthermore, the brushes act as a physical barrier. If a shoelace comes untied, the bristles will sweep it away from the gap, preventing the string from getting caught in the gears and pulling you down. In 2000, global safety codes like the ASME standard officially mandated that these skirt deflectors must be installed on escalators all over the world. They are legally required pieces of safety armor. We live in a modern world where we are completely insulated from the massive, terrifying forces of the machines that move us. We treat escalators like magical staircases, completely oblivious to the thousands of pounds of industrial torque grinding away just inches beneath our toes. So, the next time you're at the mall, riding up to the second floor, look down at those black brushes. Do not use them to clean your shoes. Do not play with them. You are looking at a brilliant, highly calibrated safety net that was designed to protect you from your own carelessness. Keep your feet in the center, respect the machine, and let the brushes do their silent, life-saving job.